Yeah, I have my calculator. That was correct. It's 5 times 10 to the minus 9 was the answer. Now we're going to go on to the pH scale here real quick. Before I do that though, I want to quick review logarithms, okay? Just real quick. So I have 10 raised to the second power, right? We all know that that means 10 times 10, and that's going to equal 100, right? Okay? Or you could have something like 10 to the 3, whatever. That'd be 1,000, right? Or you could even have something like 10 to the 4.5. Although I don't know what that is off the top of my head. 10 raised to the 4.5, enter. That's giving me 31,622, okay? So anyway, so we know that, right? This is hopefully not a big deal, okay? Well, what does a log do? Well, log base 10, you have the natural log base E. Log base 10, this is base 10 right here, right? A log gives you the exponent for the number, is what a log does, okay? So if I have log ten to the 2 logs base 10, it's going to give me the 2, right? But that's also the same thing as saying if I have log of a 100, it's going to equal 2, right? So it gives me the exponent to the base 10 is what it does. That's all it does. Okay, that's all it does. So for example, if I have log of 1,000, we already wrote it out. We know that the exponent base 10 is 3, right? Well, for crazier numbers, you can get stuff too. So I can have log of 31,622, and that's going to equal 4.5. Okay, or whatever other number it might have. I don't know. Log of 101. You know, whatever that is. You find my log function on here. Where is my log function? And it's giving me 2.004. Okay, which it should be close to 100, right? Anyway, that's all a log does. Okay, that's it, right? One more quick thing, or I guess I'll wait to say that, right? So now we're going to go on to the pH scale. So earlier we were using a concentration of H plus, and we said it was 5 times 10 to the minus 9, you know. So chemists don't like to use numbers like that, so they come up with a pH scale, okay? Basically, it's very, very straightforward, okay? We're going to have the pH is going to equal minus the log of the concentration of the H plus. Okay, is all it is, right? Or again, you can have H3O in there, right? That's it, right? Again, the reason why chemists do this is because it makes it easier to talk about a solution, the pH, whether it's acidic or not. Let's take a look at why do we have this negative number here? We have why do we have the negative number? Why do we have the negative? We have the negative because we don't want a negative number. So for example, let's take the example earlier. What is the pH of a solution .0 times 10 to the minus 9, that's what we had before, right? Just plug it in. It's actually very straight, it's very easy, right? pH equals minus log 5.0 times 10 to the minus 9 molarity. Punch that part in first. We're going to get a negative number. We don't have this negative here. We're going to have a negative number here. Go log. Where's the damn log function? Log 5 times 10 raised to the minus 9. Enter. And it turns out to be negative 8.3. Well, we don't want to do it negative numbers. That's why they stuck the negative in front of there. So we end up with 8.30. All right. Now, how do you determine how many numbers you have here? For the pH, the number of sig figs here, which is 2, becomes the number of decimal places you have here, which is 2. This is not 3 sig figs for the pH, okay? So 2 sig figs here, 2 decimal places. If I had 3 sig figs here, I'd have 3 decimal places, right? But basically the pH, that's it. So it's pretty easy, pretty straightforward to use actually. Now, let's take a look at a couple examples here. If H plus equals 1 times 10 to the minus 7, you might recall earlier that also equaled the OH concentration, which is 1 times 10 to the minus 7. What was that? That was a neutral solution, right? This was a neutral solution at 25 degrees Celsius. If you take the pH of that, what are you going to get? Well, this was relatively straightforward, right? pH is just 10 to the minus 7. You'd end up with a minus 7, then the minus, you'd have pH of 7. Is what you would end up with. That's a neutral solution. pH of 7 is a neutral solution. Remember, if we have our H plus solution is greater than 1 times 10 to the minus 7, what did we have? We have an acidic solution. Now, be careful here, okay? Because that little minus there can mess you up, all right? Just real quick, if I have 1 times 10 to the minus 6, would that be larger or smaller than this number? It'd be larger, right? It'd be larger. 1 times 10 to the minus 6 is larger than that number. 1 times 10 to the minus 5 is larger than that number. Remember, this is telling you how many zeros you're going to have, okay? So 1 times 10 to the minus 7, H plus, greater than 1 times 10 to the minus 7, that's an acidic solution, which would mean that the pH is greater, or sorry, not greater, lesser than 7, means it's an acidic solution. Okay? For H plus greater than 1 times 10 to the minus 7, you can plug this in your calculator and see, your pH will be less than 7, that's an acidic solution. For H plus less than 1 times 10 to the minus 7, okay, so 1 times 10 to the minus 8, for example, would be smaller, okay? We're going to end up with a pH greater than 7. Oh, that's not terrible. And we're going to have a basic solution, okay? So pH equal to 7, neutral solution. pH less than 7, acidic solution. pH greater than 7, basic solution, okay? Now you don't have to memorize all this or whatever. You just plug this into your calculator and you'll get it out, right? So you don't have to memorize that. You should know this. You probably already knew this, or hopefully you should have known this, okay? Sorry, I'm looking here. Let's take a look at practice exercise 16.6. Just real quick, it's pretty straightforward. Also on page 663, if you have your textbooks, okay, I suggest you take a look at the figure 16.5 on page 663, right? They show the H plus concentration, the OH minus concentration, and they show the pH in a table. And obviously, as the acid strength increases, right, your H plus concentration goes up, your OH minus concentration goes down. or vice versa, right? Again, I suggest you check out that table if you have your book. All right, here they have in a sample of lemon juice, the H plus concentration equals 3.8 times 10 to the minus 4. What is the pH? Well, that's pretty straightforward. Asking for the pH. Concentration of H plus is 3.8 times 10 to the minus 4. Simply plug it into the pH calculation. Right? Stick your number in there. Plug that into your calculator. You'll end up with 2 decimal places. You have 2 significant figures there. Raised to the minus 4. And I'm getting 3.42 for the pH. Okay? Let's look at one a little bit more complicated. Let's take a look at B. Let me erase this. It asks, what is the pH when the OH minus concentration is 1.9 times 10 to the minus 6 molarity? So again, we want to know the pH. This time they give us the OH minus concentration equal to 1.9. Sorry. Times 10 to the minus 6 molarity. So this one's just a little bit trickier, okay? Not really though, it's pretty straightforward. So we want the pH, right? So to get the pH, what do we need? We need H plus concentration, correct? Well, we can use the autoionization constant to figure that out, okay? We can go Kw equals concentration of H plus, like that, and then we're simply going to solve for concentration of H plus, right? Again, divide through by the hydroxide concentration. That cancels. Flip this around. Stick in my numbers in here. 1 times 10 to the minus 14 divided by 1.9 times 10 to the minus 6. Gonna need my trusty calculator for that bad boy. Divided by, let me use a parentheses on there, just to be safe. And I am ending up this thing, I gotta count the zeros. 3, 6, 7, 5 times 10 to the minus 7. Actually 5.0, sorry, there's 2 sig figs there. 5.0, sorry. And then just plug it into your pH calculation. Right? And what's that going to give you? And then, sorry, where am I at? Long second answer. And I am getting 8 points, since we have 2 sig figs, I take 2 decimal places, 8.278. So I'm going to drop that 8, I'm going to round up, and I'm going to get 8.28 for my pH. Okay? Hopefully it's not, hopefully I explained that well, so it's understandable. And then we're only gonna have one more thing from this chapter. There are other pH, or there are other scales, P scales. So we could have a POH scale. Nothing super complicated. Minus log of the OH minus concentration, that's it. That's the POH. Now, without going into too great of detail here, do I want to go through that? Should I go through that? I guess I'll go through that. All right, so we have that, right? And then we have the pH equals minus log of H plus. We can take a look, we can go Kw. Right? Now we can take the minus log of all of these, right? Of this, and then those. And because of the rules of logarithms, we can do this. Don't worry if you don't remember all this, okay, the rules of logarithms. You take the log of both of these, but you can split them up. It's like adding them instead, okay? Well, what is this? This is pH. What is this? This is POH, right? What's Kw? Kw is 1 times 10 to the minus 14, right? You take the log of 1 times 10 to the minus 14, basically 10 to the minus 14, what are you going to get? You're going to get minus 14. You have that minus there, so you get 14. So basically, long story short, pH plus POH equals 14, all right? And again, we've used this in some problems, but I actually, let's see here, I guess I might have one, so we'll go over this, right? But so we have pH plus POH equals 14, right? And this is all related to Kw, right? Because as your H plus concentration increases, this